Wide area networks, network evolution, and modern troubleshooting. Good day, everyone. I am Philip Andrew Cosalan, and today I'll be presenting a complete and detailed breakdown of three major pillars in data communication and networking: wide area networks, network evolution, and modern network troubleshooting. This presentation is built to show not only the theory, but also how these concepts are applied in real-world enterprise environments. By the end of this discussion, you will see how one connects the world, how networks evolve into modern intelligence systems, and how professionals troubleshoot using advanced tools and methodologies. So what is a wide area network, or WAN? A wide area network, or WAN, is a telecommunications network that covers large geographical areas. Unlike LAN, which are limited to campuses or buildings, WAN enable communication between distant branches, data centers, remote workers, and cloud servers. Companies rely on WANs to centralize services, enforce unified security, and maintain operational continuity across different locations. Simply put, if an organization has multiple branches, nationwide or worldwide, they are definitely using a WAN. Why WANs are important in modern business? WAN matters because modern business are no longer confined to one location. Every transaction, every email, every login request, these all travel through WAN links. In the Philippines, major banks rely on WAN connections to synchronize ATM nationwide. BPO companies use WAN for VoIP systems. Logistic companies depend on real-time data synchronization to track deliveries. WANs are the backbone for modern communications. So, WAN connection types. There are four main WAN connection types used today. First, dedicated lines. These provide private, stable, and secure connectivity. They are expensive but favored by banks and enterprises. Second is the packet switch networks like MPLs. MPLs is fast, traffic engineered, and support QoS, making it ideal for voice and mission critical data. The third one is the Broadband WAN, uses fiber or LTE, cost effective and suitable for small businesses. And lastly, the SD-WAN, the most modern approach, using intelligent routing, dynamics links, switching, and centralized cloud-based management. So SD-WAN, the modern standard. SD-WAN is now the most popular WAN solution. It replaces traditional MPLs by using software-defined policies that allow real-time traffic steering. It lowers cost, boosts performance, and enhances failover because it has combined multiple connection types. Fiber, LTE, DSL, and intelligently decide the best path for each application. This is why companies shifting to cloud platforms like Azure and AWS adopt SD-WAN today. Network evolution, traditional to modern. Networking has evolved drastically over the last 3 decades. Before, everything was manual. Configurations, routing, firewall rules, network were static, predictable but limited. Today, networks are dynamic, automated, virtualized, and heavily integrated with cloud technology. This evolution is driven by increasing demand for mobility, scalability, stronger cybersecurity, and cloud deployments. Virtualization and cloud integration. Virtualization revolutionized networking. It allows us to run multiple virtual routers, firewalls, and load balancers on a single physical machine. Cloud integration amplified this even further, because now infrastructure is no longer tied to a physical location. For example, companies can deploy a virtual router on AWS within minutes, connect it to their on-premise infrastructure through a VPN, and instantly expand their network capability. Software-defined SDN or SDNs. SDN separates the control plane and the data plane. This means that instead of logging into each with individuality, network engineers can manage the entire network through a centralized controller. This leads to faster deployment, reduced human error, automated configurations, seamless scaling. SDN is essential for cloud data centers and enterprise networks with thousands of managed devices. Network automation is the future. Automation is now the heart of modern networking. Tools like Ansible, Puppet, and Python scripts are used to configure thousands of routers instantly. This reduces downtime, prevents misconfiguration, and strengthens security. Large companies no longer rely on manual configuration. Everything is automated, tested, and continuously monitored. Network troubleshooting fundamentals. Troubleshooting is a core skill for network professionals. It requires a combination of logic, experience, proper tools, and consistent methodology. The goal is simple: identify the root of the cause and restore the connectivity with minimal disruptions. Next is layer-based troubleshooting, or the OSI method. The OSI model is the most reliable troubleshooting guide. Start from layer 1, checking physical cables, the layer 2, checking switches or MAC tables, layer 3, routing, subnets, and IP conflicts, and layer 4 to 7, applications, servers, security features. By allowing this structured approach, we avoid wasting time and ensure we don't overlook basic issues. Modern troubleshooting tools, infographic. Troubleshooting today uses advanced tools, ping and traceroute for connectivity and path testing, Wireshark for packet capture and deep inspection, SNMP and syslog for monitoring alerts, NetFlow for traffic analysis, Nmap for host or port scanning. Each tool has a specific purpose, allowing professionals to quickly detect anomalies, attacks, and performance issues. Real-world troubleshooting scenario. In real company environments, issues can come from anywhere: physical damage, misconfiguration, congestion, cyber attacks, faulty routing tables, or DNS failures. A proper troubleshooter must 1. Identify the symptoms. 2. Collect information. 3. Test using tools. 4. Isolate the cause. 5. Apply the fix. And number 6. Monitor post-repair performance. This systematic method ensures the network remains stable. So the future of networking. The future is shifting towards AI-driven networks. AI will automate traffic optimization, predict failures before they even happen, and provide self-healing networks. Combine this with SD-WAN, cloud adaptation, and edge computing, and we are entering a fully intelligent, global, connected digital ecosystem. So the conclusion, to summarize, WANs are the backbone of large-scale communications. Network evolution transforms traditional systems into dynamic, cloud-integrated infrastructures. Modern troubleshooting ensures stability, reliability, and security. These are three domains shape everything we use today, from banking systems to cloud services to the internet itself. And that's the end of my presentation. Thank you for listening.